So I've been doing a few videos on this twist and flex style ice maker that's found inside the freezer drawer of certain LG refrigerators. Now this particular model number is actually found in a variety of different brands, and long story short, ice was filling up in the tray too much. It became a solid clump. Thus, when it twisted and flexed, the ice clump wouldn't come out, and it would turn back over, fill back up, and water would overflow and freeze everything in the freezer, with ice just covering everything. So I'm going to just break down all of these components and try and figure out where everything went wrong. And there's actually quite a bit to go over. And I'm going to apologize in advance because I am filming with just one hand on the camera, one hand to do everything else. So please bear with me. So first off, we're going to go over the frame. Now this is the thing that holds everything together. To put this into the refrigerator, we've got this piece that slides in to a keyed position on the top side of the freezer. So you would tilt, slide this in, and then we have a clip, one on each side, that clips into place, and then we have two retaining screws, one on each side. So everything that holds the frame into place is mirrored. So that's what holds most of everything. Next up we have the on-off switch, which just pushes in place into here. Now to get this undone, all you need to do is just push down on the switch on both the top and the bottom, and it pulls right out. And to get access to the bottom portion of it, there is an access hole that you can just put any sort of object in there, and that way you can actually push the bottom in while you're pushing the top in. Comes right out. It's got two electrical connections, and these are those electrical connections. They're insulated. I think these are spade connections or something like that. Whatever they're called. I apologize for not knowing the proper name, but you get the idea. As you can see, there's a male and female end, and they just connect to each other. I don't think there's a polarity that matters. This just either completes a circuit or kills the completed circuit by disconnecting the circuit. So that's more or less the frame. There are places where wires are routed. This right here is where water drips down and then feeds into the twist and flex ice tray. Now it's called a twist and flex because just like with a regular style any old ice tray, this actually does twist and flex. That's what it's designed to do. So when it fills up, the idea is it's supposed to fill up all 10 ice cubes. It'll turn, and then a certain position, it'll actually twist this ice tray, and that's what releases them from each individual little spot. And that's how you get 10 ice cubes at once. But now we're going to talk about this. This is a sensor of some sort, and I really actually don't know what the sensor does. But we're going to take it apart nevertheless. There's two little holes that go into this where a plastic connection sits. So we're just going to push this in. It's pretty flexible, so the chances of you breaking it are pretty slim. There is a styrofoam piece that it connects to that pushes down on this little sensor, which is shaped to cradle itself in between the little V slot here. If I shake it, it almost feels like there's something in there, but I really can't confirm. I'd have to cut this thing open to actually know, but it's a sealed connection. And that goes to the main wiring harness right here. And that concludes what's going on in the ice tray here. This is the actual mechanism that does everything. We got the lever that moves up and down, and this lever, if it goes down and feels any sort of resistance, that lets the sensor know that the ice cube tray is full, and then it won't continue to make more ice. We have the actual part where this connects to the ice tray. Now, my ice tray is actually broken. You'll see that it's just shattered plastic. This is actually much more of a solid connection than what you're seeing right here, if it's not broken. And this will slide over that shaft, and then this part of the tray fits in to this hole right here. And then we're left with the unit itself. Now, the model number up here at the top, I've taken a picture of it. This is what the model number of the actual entire unit is going to be, according to some Google searches I've done. And this is the information that is available. It says, be sure not to remove 4 screws at each corner, made in China, Park Electronics Co. Ltd, blah, blah, blah. I don't care about breaking it. It's already broken. I've already replaced it. It's made with ABS plastic. So this is the part, and I've already taken it apart, but I've also reassembled it back to the way it's supposed to be. And it's not a whole bunch of complicated stuff, honestly. Now, there are some gears, there are some springs, and be aware that there are small parts. And everything is coated in a lubricant of sorts. So my hands are all slippery from that. So if this goes south, well, so be it. And by the way, the reset switch is down here, and let me see if I can take this off. You know what I'm going to do? I'm going to pause the video, I'm going to slide this off, and then I'll continue from there. Okay, so this is the inside of the unit. You'll see there's a spring on the bottom right and the top left. So this lever is connected to a series of components, and these gears are connected ultimately to the motor. And I am going to just disassemble it. Now, the fact of the matter is that spring right there is probably going to fall out. So there's really just nothing I can do about that. But the goal here is to document everything that I see in here for you guys. So let's go ahead and take this main gear off, which this shaft that goes to the lever arm does connect down here. On the bottom, you'll see on the back side of this gear, there is a slot for it to travel. So as this turns, that's what's moving this lever, thanks to this shaft right here. So that shaft fits in part of the gear. That's how it moves up and down. Now, it is retained by this, it's got some force to make it go up and down due to that spring. Here's the reset relay glued in there. And here is another lever that is connected via a spring. Now, we're going to take this off further, which requires me to remove that spring. And we're going to pull this gear off. And this gear is also connected to a set of arms. And that is what this looks like. Now, there is a little piece of metal or something on the end here. I'm not entirely sure why. Perhaps it's a magnet of some sort. Couldn't tell you. But this has a hole that fits directly over this part of this gear where it sits. And this is where you're going to notice everything is just lubricated, which is not a bad thing. So now we're left with this. We've got the motor, a shaft with a worm gear that connects to a gear that goes to a reduction, and I believe this is designed to increase torque. Yeah, I believe that increases torque by the way it's designed. Now this gear just simply slides over this shaft right here. So we're going to put that aside. And you'll see this is where the wiring comes in. Sits under all that. And then we've got this gear, which slides over its respective shaft. And then we've got the worm gear connected to the shaft of the motor. Now then, looks like the motor has some wires that it's soldered to. Okay, that makes sense because we've got an electrical board underneath here. And that electrical board is held in with 2 screws. So I'm going to try and get this motor out and see what I can't do. But I'm about to reach a 10-minute limit on this, so I'll continue this in a second video.